All right, so if we have a histogram, we can quickly look at the histogram and be able to estimate where the mean, median, and mode lie. So remember, mean, median, mode, they're all ways that we have to describe where a data center is, or about where the data or bulk of the data lie. Okay, so I say draw pictures to illustrate where the mean, median, and mode occur on data sets that are skewed left, skewed right, and symmetric. All right, so on this first graph I drew, I have test scores here on the x-axis, and on the y-axis I have frequency. So first let's identify where the mode is, or the test score that occurred the most often. Well, here's the tallest bar. So the mode must be right in here. The mode always corresponds to the tallest bar, because the tallest bar corresponds to the score that occurred the most frequently. So the mode's right in here. Now we got to ask, well, where would the median be? Or where would the middle test score be? Or where would the point be where half of people scored above that number and half scored below that number? And now just by eyeballing this, I can say, oh, the median's going to be right here. And you could say, well, how do you know that? Well, look right here. If you go to the right of this point, you have 9 test scores plus 8 test scores plus 1 test score gives you 18 test scores. So I have 18 test scores to the right of this spot. Now to the left of this spot, I have 7 test scores plus 5 test scores plus 3 test scores plus 2 test scores plus 1 test score. Well, 7 plus 5 plus 3 plus 2 plus 1 is 18. So to the right here, I have 18 test scores. To the left here, I have 18 test scores. So that must mean the median is right here. Now, people get very hung up on trying to estimate where the median is. I mean, you're just supposed to eyeball it. So you're trying to find the spot where if you add up all the heights of the bars to the right, it equals the height of all the heights of the bars to the left if they were added up. So if you add up all these bars' heights, you're going to get the same height as if you added up all these bars' heights. And again, we're just eyeballing it right now. We're not. If I just give you a generic picture and I say where the median is, where's the median? Well, I'm just asking you really to take a guess. And so here's a reasonable guess. I mean, to the right of this point, looks like the bars all add up to the same height as to the left of that point. All right, now where's the mean, or in other words, the average test score? Well, if you look at this histogram, we have a whole bunch of low test scores here. And low test scores will pull down the average. If you have a whole bunch of people in the class getting 5% and 10% on tests, that's going to bring the average test score way down. So the mean, just by eyeballing it, I'm going to say, well, the mean is right about in here. So maybe the mean's right there. If you have a left skewed histogram, in other words, you have a tail on the left, the mean is going to get pulled towards the tail. It's going to get pulled in the direction of the tail. The reason is if you got these low test scores, they're going to pull the average down towards them. Now, in a right-skewed histogram, well, the same reasoning holds as over here. It's just everything's the mirror image. So the mode would be right here, median would be right here. The mean, it's getting pulled towards the tail. It's getting affected by high test scores maybe, or if this was test scores, it'd be getting affected by the high test scores, and the average would be pulled a bit to the right. The mean is the balance point of the curve. So if you're trying to balance this curve on your finger, well, the spot that would cause the curve to balance perfectly on your finger, that would be the mean. So you can think of the mean as the balance point in your picture. All right. Now, if you have symmetric data, and in this case we have normally distributed data. So remember, symmetric means right half of the graph looks just like the left half. Now this data, it is normally distributed, meaning it has a bell shape to it. So if you have symmetric data, or if you have normally distributed data, I should say, the mean, median, and mode will all be the same number. They will occur directly in the middle of your graph. So we know the mean is going to lie there because high test scores are going to balance out these low test scores, and when you take the average, you'll get a number right in the middle. Same with these really high test scores and these really low test scores. They're going to balance each other out. When you take the average, you'll get a number right in the middle. The median, well, if you stack up the bars to the right of this point and you stack up the bars to the left of this point, the heights will be the same. So the median's got to be right here. You have the same amount of data to the right and to the left. Well, the mode is also right there. The tallest point on the histogram is right in the middle. The tallest bar on the histogram is right in the middle. So the mean, median, mode are all the same number in normally distributed data.